Well, greetings, mathletes, and welcome back. We're going to continue our exploration of factoring today. We're going to be looking at two items in particular, and they're both items that we can factor with a formula. The first one we actually saw in the last lecture, but we factored it by master product and grouping instead. But we're going to have a formula for it this time, so we can jump straight to the answer. The other one, there's really no, there are other ways of getting to the answer, but they're pretty much beyond this class. So, what we will end up doing with those is just using the formula. And so, in any case, we might as well get started here. So let's take a look at what we got. Okay, so the first couple patterns that we're going to look at are the sum and difference of squares. So I did it again. Let me just change that real quick here. There we go. Okay, so oh, that handwriting is awful. Let me try that one more time. Got a little carried away with myself there. Okay, so the difference of squares, and basically, the thing you're looking for with the difference of squares, you're looking for some situation where you have something squared subtracted from something else squared. Now, they don't have to be variables squared. It could be a number squared, right? So if you have a number like 4 or 9 or 16, those are squared numbers. So before when we looked at this, in fact, I think this was the example we looked at before or something similar to it. What we would do is we'd look at the master product, right? 4 times negative 25 is negative 100, and we added that 0 term in the middle so we could have a sum of 0. We ended up finding negative 10 and 10. So we can split up the 0. Right? And we can factor this thing by grouping. Let's see here. Common fact. I switched from A to X somewhere. Let's try that one more time. Okay, there we go. Now we got all the right variables. In any case, splitting it this way, let's see, we have 2a looks like is the common factor, so that leaves me with 2a minus 5. And then back here, it looks like 5 is the common factor, leaving us with 2a minus 5. And 2a minus 5 is my common factor. And that leaves me with 2a plus 5. Right? And so we have a nice clean method that works out this problem. But here's the thing. All this work in the middle could actually be skipped if we just make some observations here. So here's what I'm going to do. I want to just go ahead and erase some of this stuff down here, and I'm just going to bring the answer up so we can put it right next to the problem and take a look at it. So let's get all this work out of here, because there really is a much simpler way of doing this. Now, the answer we got was 2a minus 5 times 2a plus 5. Right? Okay, so I want to make some observations. So first of all, the first term, 2a. Did you notice that if I take the square root of 4a squared, I get 2a? Because 2a times 2a is 4a squared. Right? So that means that this term, the first term in each one of these factors is the square root of the first term here. And then the second term. Well, I have 25 as the second term of the original problem. If I take its square root, I get 5. And you notice these are also 5s. Now, it actually turns out that this is always true. And so we can use that to scribe out a pattern that we can use every single time. So if I have a squared minus b squared, so let's look at what we noticed. We noticed that the first term is the square root. The first term of each factor is the square root of the first term here. So That means, let's see, the square root of a squared is a, so I'll write that down. The square root of b squared is b, so I'll write that down, and then I get a plus and a minus. And that's what I'm going to do with every one of these problems that I can identify as the difference of squares. So let's see if we can actually do that. Let me go ahead and kill some of this work here. We'll look at a second example. I suppose if you didn't get that down, you probably have to rewind this video and take a look at it, but that's okay. It certainly can't hurt you to see it twice. Okay, so let's say I have bad handwriting. Yes, I do have bad handwriting. I'm way ahead of you on that one. Okay, so x squared, let's do minus 16, right? Let's say we are needing to factor this problem. So just like before, remember we said we always want to look for a common factor first. I don't see any common factors here other than 1, so that means I can proceed. And with this, I can actually speed this process up a bit because of this formula. So instead of going through the whole master product and grouping, I'm just going to ask myself, what's the square root of 9x squared? Well, it's 3x. The square root of 9 is 3. The square root of x squared is x, so it's 3x. That means the first term in the factors is 3x. I know from the formula it's always plus and minus, so I'm just going to put a plus and minus, and then I need the square root of the second term. Square root of 16 is 4, so I'm just going to write that down. And I have now successfully factored this thing. No muss, no fuss. I don't have to find a master product. I don't have to go through a grouping issue. I can just jump straight to the answer. And it's kind of nice, right? It's just a matter of recognizing that the first and second terms are perfect squares, and then noting that it's a difference between them, right? There has to be a subtraction in between, otherwise this won't work. Okay, so those go pretty quick once you recognize them as the difference of squares. Now, so let's take a look at another one here. So keeping in mind everything I just said, let's see what you can do with this one. So go ahead and pause here and see if you can factor this. So remember the steps. You want to look for a common factor, and then you're going to look at everything else and see if anything else factors, right? So there's going to be multi-stages in a lot of things, and I'll just let you in on a secret. This one is multi-stage. So go ahead and pause it here. Okay, so I'm assuming you've paused it. So let's go ahead and get started. Looking at this, if I look across both of these terms, I can see between 12 and 3 that 3 is a common factor, and between a cubed and a that a is a common factor. Okay, so let's see what we have left after that. So if I pull the 3a out, that leaves me with 4a squared. And if I pull the 3a out of there, that leaves me with minus 1. And so we have to ask ourselves, do any of these pieces factor? Well, 3a is a monomial, right? Monomials don't factor. Those are always prime. 4a squared minus 1 is the difference of squares. 4a squared is probably the more obvious square. The minus 1, though, 1 is always a square. In fact, 1 is a little bit of everything. 1's a perfect square, 1's a perfect cube, 1's a perfect fifth power. Whatever power you raise 1 to, you get 1. So it's every root also. So that means I can go ahead and factor this. So we have our difference. We put down our bubbles here. Square root of 4a squared is 2a. The square root of 1 is 1. And then I just need a plus and minus in here. And the 3a comes down afterwards. So I actually have 3 factors in this particular example. Right? Okay. So let's go ahead and take a look at the next one. Oops, I wanted to hit that. Oh my goodness. My cat's going crazy. I don't know if you can hear that or not. All right, so let's look at the next one here. Suppose I have, where is it? There it is. Suppose I have a pen that works. Okay, let's try this again. Suppose I have 81 t to the fourth minus 16s to the fourth. Okay, so this one's going to be a little bit tricky. I will tell you this much. By the time you're done, there are 3 factors. And I want to see what you guys can do with this. This is a multi-stage factoring. I want to see if you guys can work this out. So go ahead and pause this here and see what you got. Give it a little thought. Push your pencil around, and then we'll look at it together. Okay, so pause here. Okay, so let's go ahead and take a look now. Now, this usually throws people off because of the fact that it's fourth powers instead of squares, right? But I do want to point something out. If I take the square root of 81 t to the fourth, that's a perfect square, right? Just because it's a fourth power doesn't mean it can't be a square. In fact, any power that's even can be rewritten as a square. So if I ask myself what times what is 81, that's 9. What times what is t to the fourth? Well, that's t squared. And then 16s to the fourth, I can also take a square root of, and I get 4s squared. So that means that these are the square roots of these things, and those are going to be the terms in my factorization. So I have 9t squared minus 4s squared, and then 9t squared plus 4s squared, right? So those are my 2 factors. Now, here's where things get tricky. You kind of feel like you're done, right? But it turns out you're not done, because this first term here is the difference of squares again, right? So 9t squared I can take a square root of. Same thing with 4s squared. So because I can take square roots of both of them, I can go ahead and factor this. So this, now square root of 9t squared is 3t. 4s squared is 2s, so I get a plus and a minus here. Now, there's the issue of this guy, right? 9t squared plus 4s is the sum of squares, and we actually haven't talked about this yet. The sum of squares is prime. You can actually verify that by looking at, looking at the master product and grouping when you try to factor it. But without exception, well, I guess the one exception would be if it had a common factor, you can pull a common factor out of it. But other than that, it's prime. Right? So you stop wherever you hit the sum of squares. There's nothing else you can do. Right? So these are the 3 pieces that we're looking at. So I want to point out what we did. We took the main polynomial, we broke it into 2. One of these pieces also broke into 2. And so we broke that up. So the idea is to break it down into as small pieces as possible. And this is as far as we can go. Now, I want to quickly address why the sum of cubes causes a problem. Because I see people try to factor it all the time, but if you actually went back and just multiplied out your answer, you'd see that it's incorrect. So that's probably the best defense you have is if you're going to factor this, if you factor something, multiply it back out. Otherwise, it's not a correct factorization. So the sum of squares is prime, right? It's always prime. Now let's look at why. So we're going to go back to the master product and grouping again, and I'm just going to make up a problem. Right? This is the sum of squares. 9x squared is a square, 4 is a square, so this is, plus is a sum, this is the sum of squares. I'm going to go back to the master product and grouping, and we're actually going to use this to verify that it's prime. So here, my master product would be 36, positives 36. The sum would be 0. Now, we have 2 ways to approach this. We can list out every possible factor of 36, or we can make some observations about the structure of this using the signs. So 36 is a positive number. So I'm using the structure here. 36 is a positive number. So that means that either when I multiply these two numbers on the side, they have to either both be positive or they have to both be negative, right? They have to be the same sign. Well, if you stop and think, if these are both positive numbers, can I add two positive numbers and get 0? You can't, right? Any two positive numbers you add, you're going to get another positive number. If they're both negative, well, can you add two negative numbers to get 0? And you can't, right? So just by logic, just by looking at the signs there, you can tell that this doesn't factor. And so there's nothing here, so it's prime. There's no common factors other than 1 either. That's actually important to note. Okay, so the difference of squares is basically, if you recognize it, you can jump straight to the factorization using the square roots. Sum of squares, if you don't have a common factor, it's prime and you're done, right? So this is a nice thing to recognize for knowing when to stop working on something because it's prime. All right, so now the next two things we're going to look at are the sum and difference of cubes, okay? Now, with the sum and difference of cubes, at this level, there's really no other way to go than to just use the formulas. And they do look a little more complicated than the difference formulas. So let's look here. So we got the sum of cubes and the difference of cubes. And what's nice about math is everything is named for what it is, right? The sum of cubes, you just think about it. What's a sum? That means plus. Cubes, something to the third power. So if I have sum of cubes, I'm taking two numbers that are raised to the third power and adding them together, right? Difference of squares. A difference is subtraction. What were we doing? We were taking two squares and subtracting them. So things are named for what they are. But the sum of cubes, right? Here's two cubes, and I'm taking their sum. So that means that whatever a and b are the cube roots of these terms. Now, it turns out that when you factor these, the two formulas are very similar. They only differ by a sign in a couple places here. So let me just write these down. So there's a binomial term first. And the binomial term, you notice there's no cubes on it now. So these are the cube roots of these terms, and we just add them together, right? So this sign matched this sign. Then the second term is all the ways that you can multiply a's and b's together. I can multiply a by a to get an a squared. I can multiply a times b, or I can multiply b times b. That's a b squared. This last term is always positive, and this one's negative here. Here's the thing about the positives and negatives. It actually turns out in the difference of cubes, the only difference between the two formulas are these two signs right here. Those are switched, right? Both signs are flipped with the difference formula. You'll see here in a moment. So if you memorize one formula and then remember how it changes to the other one, you only need to memorize one formula. All right, so the difference of cubes would be a cubed minus b cubed, and that gives me a minus b times a squared plus ab plus b squared. So again, right, these signs here, that's the big difference between the two formulas. Things I've noticed that help me remember the formula in the long run. This sign is always the same as that sign, right? Those match. You only get one negative in any of the factorizations, right? It's either here or it's here. So if I know this is plus, I know my minus goes here. Down here, if I know this one's minus, I know that one's plus. And so I get that from the original problem. Other than that, you really should memorize these. These are one of the few factoring things that you really should memorize because they do pop up quite often. and it's a very useful thing to be able to use. Okay, now let's go ahead and actually look at one of these, because really what this ends up boiling down to is recognizing the pattern and plugging everything in. Okay, so I kind of wish I could make that a little bit smaller, but okay. So let's take a look at a problem here. Let's say I have x cubed plus 8y cubed, and I need to factor this, right? Is that going to leave me enough room? Probably. Okay, so here's how I like to do it. I like to, right below the problem, especially while you're getting used to it. You notice this is a plus, so this one's going to be a plus. I like to write down the formula. Because I know that's where everything's going to go. Then what I need to do is figure out what a and b are. Now, since I'm dealing with the sum of cubes, a is going to be the cube root of the first term. And a cube root, it just means what times itself 3 times gives you that number. And so that ends up being x. And b is the cube root of 8y cubed, which is 2y. So now I know what a and b are. And it's just a matter of plugging them in up here. Okay, so I have a plus b first. So this is x plus 2y. And then over here, I have a squared, so that'll be x squared, minus, let's see, a times b, so that's 2xy, and then b squared, so that's 4y squared, right? And now I have it factored. I probably should have written it down here or something, but yeah, and I'll just write it again. I don't know how big that is on your screen. Right? And that was the factorization of x cubed plus 8y cubed. So again, you notice if I take the cube root, that's this, cube root of this term is that, cube root of this term is that. Once you have those, you square the first term, that goes here, multiply the first times the second, that goes here, and then square the last term, and that goes here. Right? So there's patterns in here, and those are just the patterns I notice. You may notice a completely different pattern that works for you and is completely correct. And if that is the case, I absolutely encourage you to do that. It's actually better if you can come up with a system of your own, because you will understand it a lot better if you can come up with stuff on your own. Okay, so let's go ahead and take a look at another one of these. Oops, I wanted to do that. There we go. Actually, let's try this again. There we go. Tell you what, they don't hand these degrees out to anybody. I can solve me a problem here. Okay. Actually, let's clean that up a little bit too. All right, so let's go ahead and take a look at the next one here. And this one's going to be for you guys to play with. So let's do, I'll put it down here, y cubed minus 1. Okay, so go ahead and pause it here, identify the formula that you need to use, and figure out your a and b and plug everything in. Okay, I'll assume that you've paused it here. And again, I look at this, I see a minus between these. This is a cube. Again, one is a square, one is a cube, one is a fourth power, one is a fifth power, one is every power you want it to be. So one is definitely a cube. And that means I have the difference of cubes. I have a cubed minus b cubed. Here's a word of advice when you're trying to remember new formulas. A good way to memorize them without having to go through flashcards and everything else is when you're going through the homework, every time you use the formula, write the formula down. If you do that every single time, most of the time, by the time you get to the end of the homework assignment, you have it memorized or mostly memorized, and you've saved yourself a ton of work without doing too much extra. So get in the habit of doing that. It really does help. Just every time you use these formulas, jot them down, even if you don't need to, because it just reinforces it in your mind. And you'll find by the end of the homework assignment, you're writing it down without looking at it. Okay, so the formula then is a minus b times a squared plus ab plus b squared. Right? That's our formula. So we just need that formula to get plugged in. So we have to figure out what a and b are. So a is the cube root of y cubed. Right? So what times itself 3 times gives me y cubed? Well, y cubed means y times itself 3 times. So it's got to be y. B is the cube root of 1, which is 1. So now that we have all those pieces identified, that we know A is y and B is 1, I just need to plug them in. So A is y, B is 1. Now I need a squared, so that's y squared. A times b is 1 times y, and then b squared would be 1 squared, which is 1. And so you end up with this polynomial, or these factors for this polynomial. Okay. It's funny, I really have a hard time. I'm in a very strong habit of pausing after problems to ask people if they have questions or to let people ask them. But there's no one here to ask. Oops, I keep doing that too. Okay, there we are. Let's do this. All right, so let's take a look at another one. So I'm going to add one more layer onto this. This one's actually going to have 3 factors. Let's see what we can do. Got that. Okay, so we got 2x cubed plus 54. So go ahead and pause here, take a few minutes, see what you can do with it, and then go ahead and play, and we'll take a look at it. Okay, so let's see here. So the first thing we always do, if we remember here, is just kind of glance over and look for a common factor. So I can see that both of these numbers are even, so that means 2 goes in. There's no x in both terms, so we'll just pull out the 2 and see what happens. So we got 2, that gives me an x cubed plus 27. And now we need to look at what we have. So that's a cube, and that's a plus. So let's see, 27 is 3 cubed. So that means that we have the sum of cubes here. Okay, so remember the 2 is still a factor. He's just along for the ride now. He's a spectator, and he's going to watch what happens with the rest of this stuff. So again, a cubed plus b cubed is equal to a plus b, let's see, a squared minus ab plus b squared. It's a good idea to write this down every time. I know I've said it before, but the more times you write it down, the more patterns you start to notice inside the formula that allow you to remember it easier, right? That's why it works. Okay, now, so if we're going to factor this, we know that it starts with the 2, but I just need to break up this guy. So let's figure out what a and b are. So a is the cube root of x cubed, which is x. And b is, there we go. b is the cube root of the second term, which is 27, which is 3. So if I have a plus b, that's going to be x plus 3. And then I usually build the next part off of this x plus 3. Right? It's x times x. So that's x squared. I need that negative in here. I know that negative is going to be there, but then it's x times 3. So that's 3x. And then 3 times 3, which is 9. And so we have this thing factored now. Now, a word of warning. This is just a word of caution here. This second piece over here, that's a trinomial. It looks very much like it should factor. It really, really, really does. It never factors. The only thing that might happen is you might have a common factor. Like if I forgot, well, it won't work with the two anyways, but if there was a common factor I could pull out and I didn't pull it out and it still factored, then I'd be able to pull the common factor out at the end. But other than that, this thing is always prime. So I'm going to save you some work by telling you that ahead of time. I know for me, I there were many times as a student where I got hung up trying to factor this second piece, convinced that it would factor because it looked like it should, but it doesn't. It's prime. In fact, it wouldn't be part of the formula if it factored more. There would be the two pieces, the pieces that it factors into would be part of the formula instead. Okay. All right. Now, I do want to point out a couple of other things, and these are just things that might help you along the way. It is a very good idea to be familiar with your cubes, right? So things that really help with this, in fact, it's a good idea. Just if you don't want to do it by hand, just pull out your calculator and start looking at cubes, right? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, right? It keeps going and going and going. 7 cubed is 343, 8 cubed is that 2? Wait, no, that's not right. 8 cubed is 512. Yeah, you can see where this is going. 9 cubed is 721, right? So these 10 cubed is 1,000, right? So those are your first 10 cubes. I can almost guarantee you, you're not going to get too many cubes past that. So if you're familiar with those few, and most of us are familiar with the cubes up to 5 anyways, so there's not that many more to look at. But you don't even have to necessarily have them memorized. Just recognize one when you see one. It's a great big help just to have a list of cubes around, so that you can recognize the sum and difference of cubes when you come up on one. Okay, so that's what I wanted to cover today. And so until next time, keep your pencils and your wits sharp.